In 2026, Amazon is planning to invest $200 billion into building out their infrastructure. That's data centers, AI chips, basically all of the physical stuff that powers the services and the applications that we all use on the internet. Now, to put that into perspective, $200 billion is more than the entire GDP of most countries. And the biggest share of that investment is going into AWS, Amazon's cloud computing business. Barclays expects AWS revenue growth to hit around 34% by Q3 this year. AWS is already running at over $140 billion a year in revenue, and it's not slowing down, it's accelerating, speeding up. At the same time, Anthropic, the company behind Claude, just had a $6 billion revenue month in February of 2026. That is more revenue than the entire annual revenue of companies like Databricks and Snowflake, which are some of the greatest software companies that we have ever seen before. And by the way, February is only 28 days. And where does most of Anthropic's AI actually run? On AWS infrastructure. Hi, I'm Suleiman. I've been working in tech since 2015 when I was just 18 years old, and now I'm running my own businesses across cloud and AI consulting, software, and my education company, where I've helped more than 900 people master cloud engineering and land six-figure jobs, including at companies like AWS. So whether you are already in tech, trying to break in, or just want to stay ahead of the curve when it comes to AWS, what I'm about to break down today might be the most important video that you watch this year. And I don't say that lightly. Now, before I go any further, I want to make sure that we are on the same page on what cloud computing is. Traditionally, if a company wanted to run a website or an application, they had to buy their own servers, physical computers that are essentially more powerful versions of the computer that you have at home. Those servers came with a very high cost of setup, maintenance, overheating, and having to guess how much capacity that you would need in advance to serve your customers. Cloud computing changed all of that. Big tech companies like Amazon, AWS, built enormous data centers filled with hundreds of thousands of servers and said to all the other businesses, instead of you going and buying and managing your own servers, you can just rent ours. We'll handle the hardware, the maintenance, the upgrades, the security, all of it. You just pay for what you use, like a utility bill. Use more, pay more. Use less, pay less. Today, when you use Netflix, that's running on AWS. When you use Airbnb, that's on AWS. A huge number of applications on your phone, the websites that you visit, the banking systems that process your transactions, they are all running on AWS infrastructure somewhere around the world. Now, most people don't realize this, but AWS is quietly powering a massive chunk of the internet. And the reason that this matters is because we are entering a new era of cloud computing, and it starts with the unprecedented amounts of spending that we are seeing with AI. Amazon is planning around $200 billion in spend this year, up from $131 billion in 2025, and with the majority going towards AI and cloud infrastructure. And then when you factor in the biggest tech companies in the world, we are looking at north of $700 billion of combined spend on AI and data center infrastructure in 2026. So what are they building? Data centers. A data center is a massive compound, sometimes the size of several football fields, filled with rows and rows of servers. These servers are packed into racks that go from floor to ceiling. The heat generated by all of these machines running at full capacity is intense. So the buildings have industrial cooling systems. They have backup power generators so that if the electricity goes out, the servers keep running. Now, these data centers aren't just filled with regular servers anymore. Increasingly, they are being packed with specialized chips designed specifically for AI. These are mainly GPUs from NVIDIA and custom chips like Amazon's own Trainium. A GPU is a type of processor that's exceptionally good at the kind of maths that AI needs. Traditional processors, called CPUs, are designed to handle one task at a time very quickly. GPUs can handle thousands of calculations simultaneously, which is exactly what you need when you're running an AI model that's processing language, generating code, making images, etc. Jensen Huang, the CEO of NVIDIA, has been calling these AI-focused data centers AI factories. And that's actually a brilliant way to think about it. Just like a car factory that takes raw materials and produces cars, an AI factory takes data and compute power and then produces intelligence. That's what these companies are building out at massive scale. Every AI tool that you use needs computing power to work on. As more people and more businesses start using AI every single day, the demand for that computing power just simply goes up. And as the demand goes up, more data centers need to be built. And as more data centers get built, more people are needed to design them, build them, secure them, and keep them running. The bottom line here is that AI doesn't work without cloud infrastructure. It simply cannot scale. It can't reach the people that it needs to reach. And right now, every major company in the world wants to use AI at the same time. That's why cloud providers like AWS are building as fast as they possibly can. AWS is essentially an AI-first company now. Let's ignore the bit of drama issues that they've been having recently, right? The outages. So why does everything point to AWS then? Why not Azure or GCP? Well, AWS has been the dominant player in cloud computing for nearly 20 years. They hold around 30% of the global cloud market, which is more than any single competitor. They serve millions of customers from tiny startups to the largest governments and enterprises in the world. And when major cloud outages happen, AWS incidents tend to be the ones that make the headlines because so many of the services and applications that we use every day depend on it. Now, that alone should tell you something about the career opportunity in learning AWS, right? If this many businesses depend on AWS, then they need engineers who know how to build on it and manage it. But what makes this moment particularly special isn't just AWS's existing market position. It's what they're building on top of it. AWS is positioning as the platform where businesses build, deploy, and run AI at enterprise scale. They're investing in custom AI chips, new services for deploying AI agents, infrastructure that you can run inside of your own data center, and a whole ecosystem of tools for businesses to use AI securely. Let me give you one example that really shows why this matters and why businesses are choosing AWS for AI. And before you say anything, this is not sponsored. This is all fact-checked, research, and real expertise that I've built through working with companies, implementing AI, implementing AWS into their businesses, migrating from on-prem to cloud, modernizing their architecture and services. This is a decade-long of experience that's talking right now. AWS has a service called Amazon Bedrock, which has over 100,000 customers from SMBs to large enterprises. Bedrock is essentially an AI marketplace and management platform. Let's say you're running a large insurance company. You have millions of customers. Every day, thousands of them submit claims. And for this example, obviously, this doesn't happen right now, but let's say each claim is reviewed manually by a human, which takes time and costs money. You want to use AI to help process these claims faster, maybe to read the claim, categorize it, check it against the policy, and either approve the simple ones automatically or flag complex ones for human to review. Now, you have a few options. You could try to build your own AI system and AI model from scratch. That means hiring researchers, training your own model, building infrastructure to run on it, and then maintaining and updating it over time. That could take years and cost tens of millions of dollars. For most companies, that's simply not realistic or a viable solution. Or you could go to Amazon Bedrock, and on Bedrock, you have instant access to over 100 different AI models from companies like Anthropic, Meta, and some OpenAI models, as well as Amazon's own models. You can then test different models to see which one handles your insurance claims the best. And if a newer, better model comes out next month, you can simply switch to it without rebuilding your entire system or your architecture. The flexibility that it gives you as a business is unparalleled. But here is the part that really matters for big companies. When your insurance company uses an AI model through Bedrock, that model runs in your own private environment. Your customer data, their names, their policy details, their medical records, none of it leaves your account and nobody else can see it. It's not being sent to a public AI chatbot like ChatGPT, which, by the way, this is what everyone's doing right now in virtually every single company. They are sending in sensitive and private information into ChatGPT. So yes, the biggest advantage of running Bedrock is that it's not being used to train Sam Altman's model. It's completely private and secure, running inside of your own controlled environment. Can you see how this is becoming a tailwind for someone who's learning AWS or considering it? Every single one of these businesses using Bedrock needs someone to set up those private environments, configure the security, connect Bedrock to the company's existing systems, and then monitor everything. That's cloud engineering at work. And AWS has reported a global shortage of 6 million cloud professionals. And as more businesses adopt AI through platforms like Bedrock, then that demand is only going to increase. In fact, most businesses are still stuck between migrating from on-prem to the cloud. This AI phase is a new phase of modernization and personalization. That's exactly what we do inside of my Cloud Engineering Academy. We've had students land roles at AWS as well as other big tech companies and startups, so we know what it takes. So if you're serious about landing a six-figure cloud role in 2026 and you want my help directly, then just check the link in the description below where you can book a call with my team. Now that you understand what Bedrock is and why businesses are using it, I want to pull back the curtain on the economics of AI. Because once you understand how the money actually flows, everything that I've been talking about snaps into focus. When a business uses AI through Bedrock, they don't pay a flat monthly fee like a Netflix subscription. They are charged based on how much they actually use. Specifically, they're being charged per token. Now, a token is just a small chunk of text. Roughly speaking, one token is about 3/4 of a word. So when you send a message to an AI model, that message gets broken down into tokens. The model processes those tokens, which takes computing power and costs money, and then it generates a response, which is also measured in tokens. So token ins and tokens out. So every conversation someone has with AI is all measured in tokens, and every single token costs money. Now, here is why this matters for AWS and ultimately for you. When a business uses Claude through Bedrock, those tokens are being processed on AWS servers. The business pays Anthropic for access to the AI model, but the actual computing power running the calculation underneath, that's AWS infrastructure. So every token that gets processed generates revenue for both Anthropic and Amazon. Both companies make money every single time someone uses the AI. Now think about what happens when AI usage grows. More businesses adopt AI, more employees within those businesses start using it daily. AI agents start running automated tasks around the clock, and it all leads to skyrocketing the number of tokens being processed. A prime example is Robinhood, who went from processing 500 million tokens per day to 5 billion tokens per day in just 6 months on Bedrock. That's a 10x increase at a single company. Now, multiply that kind of growth across thousands of enterprises, all ramping their AI usage at similar rates, and you start seeing why AWS is projected to earn hundreds of billions in incremental AI revenue over the coming years. This is the economic engine driving everything. Businesses aren't experimenting with AI anymore. They are committing real money over multiple years to run AI on AWS. And every single one of those commitments means more infrastructure that needs to be built and managed by real engineers. So then the obvious question is, who's actually driving all of this usage? Who's generating the tokens that are fueling the entire economic engine? Now, the biggest single driver right now is Anthropic. At the end of 2024, they were doing roughly $1 billion a year in annualized revenue. By early 2026, that number hit $14 billion. That's more than the annual revenue of Databricks or Snowflake, two of the most successful companies ever built. Now, I want you to really think about what that kind of spending means, because this isn't traditional IT software spending from enterprise companies anymore. What we are seeing with AI, thanks to Anthropic, is fundamentally different. Regular people and smaller businesses are spinning up Claude and getting it to do everyday tasks and work, writing code, analyzing documents, managing manual tasks. This isn't IT budget spending anymore. This is labor spending. AI is now pulling from the same budgets that used to pay for employees, contractors, and outsourced work. And that market is orders of magnitude larger than the traditional software market. And here is the thing that should really make you pay attention. The models and agents that we have right now, they are the dumbest that they will ever be. Every week, they get more capable. Every month, new products ship that make them more useful. If businesses are already spending $6 billion a month at this level of capability, imagine what happens as these tools get dramatically better over the next 6 months, 12 months, or even a year. The demand for infrastructure that runs all of this is going to be unlike anything the tech industry has ever seen before. And that infrastructure is AWS. 80% of Anthropic's revenue actually comes from enterprises. While OpenAI has hundreds of millions of individual users through ChatGPT, Anthropic has been focused on being the AI that businesses trust with their most important work. And it's working. According to the Ramp AI Index, Anthropic now wins approximately 70% of matchups against OpenAI among businesses buying AI for the first time. A year ago, that ratio was reversed. Nearly 1 in 4 businesses on Ramp now pays for Anthropic, up from just 1 in 25 a year ago. Claude has become a cornerstone for businesses and everyday people alike. And all of this comes back to AWS. Amazon built Project Rainier specifically for Anthropic, a massive AI computing cluster with nearly 500,000 Trainium 2 chips today and expected to surpass 1 million. And Anthropic is shipping new products at an unprecedented rate. Claude Code, Cowork, computer use almost daily. Every new update means more users, more tokens, more compute, and more AWS revenue. That cycle is only accelerating. And it's not just Anthropic. The entire AI industry is in a competitive race so intense that it's forcing companies to hire engineers at an extraordinary pace. OpenAI, the company behind ChatGPT, just announced plans to nearly double their workforce from 4,500 to 8,000 people by the end of 2026. And the reason is genuinely fascinating. Anthropic has been winning enterprise customers at a rate that has OpenAI seriously worried. Anthropic now captures over 73% of all spending among companies buying AI tools for the first time. 10 weeks ago, that split between Anthropic and OpenAI was 50-50. In early December, it was 60-40 in OpenAI's favor. It is now 70-30 in Anthropic's favor. That kind of shift in just a few months is almost unheard of in enterprise software. OpenAI CEO Sam Altman reportedly issued an internal code red back in December 2025, pausing side projects and redirecting teams in response to competitive pressure from Google and Anthropic. They recently abandoned their video AI generating tool, Sora. Reports say OpenAI is now refocusing on core products and enterprise monetization as competition with Anthropic just intensifies. Because the enterprise market is where Anthropic has been gaining ground the fastest. And think about what OpenAI's response is. They're looking to hire 3,500 more professionals, engineers, researchers, product developers. If that doesn't tell you something about the demand for technical talent right now, I don't know what will. Now, you might be thinking, if the demand for cloud infrastructure is this massive, couldn't companies just build out their own data center, skip AWS entirely, set up their own servers, run everything themselves, right? Basically just go on-prem. So let's walk through what that actually looks like. Firstly, you need a physical facility, a data center with cooling, backup power, fire suppression, physical security, multiple internet connectivities. Building one from scratch takes at least a year. Then you need the hardware, the servers, the networking, the storage. And if you want to run AI, you need specialized chips, GPU ones, which NVIDIA has an enormous backlog on. Even Amazon expects their own chip capacity to be heavily booked through 2026. So the startup's cost is incredibly high and you won't have access to the latest NVIDIA chips. But even if you get all of that sorted, you hit the hardest problem. How much capacity do you actually need for your business? With AWS, you scale up and down and only pay for what you use. On-prem, you have to predict your demand for months or years in advance. Build too much, you're burning money on idle hardware. Build too little, your systems crash when the demand spikes. Now, sure, if you're a mature business, you might have a very good idea of how much capacity that you need. But with AI, the usage is widely unpredictable. A business can go from thousands of queries a day to millions overnight. On top of that, the technology is changing every week. On-prem, you're locked into whatever you built 6 months ago. By the time your data center is operational, the technology has fundamentally already moved on, and in the AI race, 6 months is enough to be left behind, or your business going bust. Now, there are certain scenarios where companies do need infrastructure in their own facilities. Governments with classified data, defense organizations, banks with strict data residency laws. And even then, they are turning to AWS. Last year, AWS launched AI factories. How it works is that the customer provides the building and the power, and then AWS deploys their chips, GPUs, networking, storage, security, and AI services. It's essentially a private version of AWS running in your own facility. The customer gets all the same responsibilities as the public cloud, but inside of their own walls, meeting sovereignty and compliance requirements. Now, whether a company uses the public cloud, private cloud, hybrid cloud, or a sovereign setup, AWS is basically involved in all of these scenarios. Now, I did just mention sovereign deployments, right? But let's talk about what recently happened in the Middle East, which shows you how critical this infrastructure has become. In March 2026, Iranian drone strikes hit 3 AWS data centers, 2 in the UAE and 1 in Bahrain. These were the first known military strikes on a major cloud provider's infrastructure in history, and the impact was immediate. Banking apps were down across the region. Payment platforms platforms stopped working. Delivery services were disrupted because all of those services were running on the same cloud infrastructure. Sometimes when we talk about the cloud, it seems as though it's something very abstract, but the cloud runs on the physical data centers. Those data centers have an address, and that address can be hit by a drone. Governments are now classifying data centers as critical national infrastructure, alongside power stations and water treatment plants. The conversation about physical protection of these facilities has become very real because they are just that important, and recent events have made people realize this. And when something becomes critical to national infrastructure, that tells you everything about where we are heading. All of the spending, all of the infrastructure, all of the demand for engineers is all building towards something. The end game is that every business in every industry use AI to deliver better experiences and make smarter decisions. A bank that gives you personalized financial advice based on your actual spending. A healthcare provider that flags risks before they become serious. And just like AWS turned cloud computing into a pay-as-you-go utility over the last 2 decades, they're now doing the exact same thing with AI. AI as a service. You don't build it yourself. You don't train your own models. You connect to the platform, pick the model that fits your use case, and then you build on top of it. If a better model comes out next month, you just switch. The infrastructure handles everything underneath. And we are at the beginning of a transformation that's going to affect every single industry. And the people who understand AWS are going to be extraordinarily valuable for the years to come. So you might be thinking, all right, Suleiman, I get it. AWS is massive. I'm set on learning AWS, and I know that the opportunity is real. What will I actually be doing day to day? And what kind of careers does this open up? The main role is obviously cloud engineer. This is the person who designs, builds, and looks after this digital infrastructure. On a typical day, you might be working with a dev team to set up the infrastructure for something that they're building. So you'll be deciding which AWS service to use, how different parts of the system talk to each other, making sure that it can scale if the product takes off. You might be working on security, making sure that the right people have the access at the right time and nobody else. You might be building automation, writing code that spins up infrastructure automatically. You might be looking at the costs, figuring out where the company is overspending and how to optimize. You might be setting up monitoring so the system watches itself and it catches problems before the customers notice. And increasingly, you'll be working alongside AI teams to deploy and manage AI systems. Now, here is a part that I think most people don't fully appreciate and is one of the biggest advantages of learning AWS and cloud engineering as a whole. Cloud engineering doesn't lock you into one job title. It gives you a foundation that opens up the door to the most in-demand roles and specializations right now. With cloud skills, you can go into DevOps, which is about automating how software gets built and deployed. Platform engineering is where you build the tools that other engineers use. Site reliability engineering, focus on keeping systems running and responding to incidents. Solutions architect, designing the technical systems and blueprints for how businesses use the cloud. Cloud security, which is one of the fastest growing areas in all of tech. Systems or infrastructure engineer. The reason that you can move between all of these is that they all share the same foundational knowledge. Networking, security, automations, building systems that work reliably at scale. Once you have that foundation, you can specialize in whichever direction interests you. And if your interest changes later on, you just pivot. You're not boxed in. Inside of my Cloud Engineer Academy, I've had students land roles as a DevOps engineer, platform engineer, cloud security engineers, automations engineers, systems engineers, cloud network engineers, as well as cloud engineer, right? There's loads more, but obviously you get the point, right? The flexibility is unlike any other path in tech. And the compensation across all of these roles is 6-figure salaries and beyond. So if you're looking to land a cloud role in 2026 and you want my help, just click the link in the description below and book a call with my team. So the question is, should you learn AWS? Right now, we are at the start of the biggest infrastructure build out since the internet, and it's still so early. I've been in tech long enough to recognize when a window like this opens. And every time there's been a major technological shift, the people who moved early captured the most value, the biggest roles, the highest salaries, the most optionality. And then a few years later, when everyone else caught up, the window narrows. If you can demonstrate genuine understanding of how AWS works, how systems and services connect, how to think about architecture and security, and you can combine that with the ability to work effectively with alongside AI tools, you are exactly what companies are desperately trying to hire for right now. While most companies are preparing for this opportunity by getting certifications or watching YouTube tutorials, you can stand out by positioning yourself as someone who can solve real problems for businesses. As always, I'm rooting for you. Good luck.